This is Jacob's Algebra, Chapter 14 Review, Part 1. What we're going to do is go through the Set 2 problems. The Set 2 problems are numbered the same as the Set 1 problems. So number 1 in Set 2 corresponds to number 1 in Set 1. Number 2 in Set 2 corresponds to number 2 in Set 1. So you can watch the problem that I work from Set 2 and then go back and do the corresponding problem from Set 1. So looking at Set 2, let's look first at number 1. It says, tell whether each of the following statements is true or false. The first statement is every integer is a rational number. So that is number, get it into pen mode. That's number 1A. And it says every integer is a rational number. That is true. Because remember, any integer, and integers are numbers like 3, 7, 4, 10. These are all integers. And rational numbers are numbers that can be written as the quotient of two integers. Well, I can put all of these as fractions over 1. That means that they're all rational. All integers are rational numbers. So number 1, statement A is true. Let's look now at B. Letter B says the square root of a number can be a repeating decimal, and that is true. The square root of a number can be a repeating decimal. Okay, let's look at part C. Every positive number has 2 fourth roots, and that is also true. As long as you are taking the even root of a positive number, there will be two answers. So even roots of positive numbers will always have 2 answers. Now, if it's an odd root, then an odd root of either a positive or a negative will only have 1 answer, but even roots of positive numbers have 2 answers. Okay, part D. To every point on a number line, there corresponds a rational number. This one is false. Your immediate impulse might be to say true, but it is not true because the irrational numbers are also on the number line. And the point that you look at on a number line, it could be one of those irrational numbers. Okay, part E. The circumference of a circle is more than 6 times as long as its radius. That is true. Think about the formula for circumference. Circumference is 2 times pi times the radius. Well, pi is about 3.14, and 2 times 3.14 is more than 6, which means that the circumference is more than 6 times the radius. So that was number 1 in Set 2. It's just like number 1 in Set 1. It just has different statements. So you should go back and work number 1 in Set 1 now. Now let's look at number 2. Number 2 says, change the following rational numbers to decimal form. You can use your calculator for this. The thing that you need to be careful of is for all of these, you need to give an exact answer. Because these are rational numbers, that means that the decimal answer will either terminate or it will go into a repeating pattern. And so if it terminates, then you need to take it all the way out to where it terminates. If it goes into a repeating pattern, then you need to take it out far enough to see the repeating pattern, and then you need to write it. This is what I mean. So for 2A, the problem is 10/4. And so I'm going to pull up the calculator and clear that out, and we have 10 divided by 4, and that's 2.5. So that's one that terminates. Okay, so now let's do part B. Part B is 7/25, and when we punch that one into the calculator, 7 divided by 25, 25, you can see that one terminates also. It's 0.28. Now let's look at part C. Part C says 44/9. Okay, when I punch that one into the calculator, 44 divided by 9, you see I get this repeating pattern. So you don't want to round this off. Do not write 4.89. Do not write 4.9. Those are not what we're looking for. We need to find the repeating pattern. When you look at this, you can see the 8 is what repeats. So the answer that we want for this is 4.8 with a bar over the 8 because the 8 is the only thing that repeats. So remember, you need to get the exact answer, not rounding. Okay, part D is 2/13. So punch that into the calculator, 2 divided by 13. And you can see we get this long thing, but it has a repeating pattern. Notice we've got 1, 5, 3, 8, 4, 6, and then it repeats 1, 5, 3, 8, 4, 6, 1, 5, 3, 8, 4, 6. So my answer is going to be 0.15384, and that whole thing repeats. Now, your calculator that you have may not go out that far, but all of the problems that you have in number 2 are either decimals that terminate or decimals that have a repeating pattern. You need to carry it out far enough to see where the repeating pattern is and make sure that you put the entire repeating pattern underneath a bar. So do not round the answers for number 2. Okay, so now let's look at problem number 3. Problem number 3 says, write each of the following as the quotient of two integers in lowest terms. Okay, so the first one, part A, is 0.06. So this is 6/100ths, so we can write that as the fraction 6/100ths, and then simplify it. These are both even numbers, so that simplifies to 3/50ths, and that problem is done. Now part B is different. It's 0.06, but we have a bar over the 6. These we have to work the other way where we use n. So we set n equal to whatever number we're starting with. N equals 0.06 bar. And now we only have one thing under the bar. That means we're going to write a 1 with 1 0 after it. So we'll have 10 times n. When we multiply this by n, it means we're going to move our decimal over one place. So we're going to move it from where it is now to right here. So that means we're going to have 0.6. And we could go ahead and draw the bar here, but what I'm going to do is go ahead and repeat my pattern. So if n is equal to 0.06 with a bar, then 10n is equal to 0.66 with a bar over it. Now what I need to do is subtract, and I'm going to do that on both sides. 10n minus n, well, that must be 9n because we had 10 and we took 1 away. And on the right side, I have 0.66 minus 0.06. That's going to give me just 0.6. To solve for n, I need to divide both sides by 9. So our n is equal to 0.6 over 9. Now, this is a problem here because you don't want to leave a decimal inside of a fraction, so we're going to multiply the numerator and the denominator by 10. So we'll end up with 6/90ths. And then we need to simplify because we are not in simplest terms here. Both 6 and 90 are multiples of 3. So when I divide 6 by 3, I get 2. When I divide 90 by 3, I get 30. Oh, we can go even further. Both of these are even numbers. So when we divide 2 by 2, we get 1. When we divide 30 by 2, we get 15. So for number 3, part B, 1/15 is the answer. So let's go ahead and work part C and D from number 3. Number 3, part C is 1.125. Well, that's easy enough to write as a fraction. This part has we have 3 decimal places. So we're going to write our 1125 over 1 with 3 zeros. 3 decimal places means 3 zeros. And now we need to simplify. So what I'm going to do is divide both the numerator and the denominator by 25. When I divide the numerator by 25, I get 45. When I divide the denominator by 45, I get 40. And then these are both multiples of 5. So when I divide the numerator by 5, I will get 9. When I divide the denominator by 5, I will get 8. So 9/8 is our answer to number 3, part C. Now we're going to do part D, which is 1.125 with a bar over it. And I'm going to go ahead and, just to avoid confusion, get rid of that. Okay, so we have 1.125 with a bar. So we're going to set n equal to 1.125 with a bar over the 125. Notice how I'm leaving plenty of space here. The reason for that is because I know I'm going to multiply the n by something. What I need to do, the number of zeros, I'm going to multiply n by some multiple of 10. Because I have 1, 2, 3 decimal places here underneath the bar, that means I need to multiply by a 1 with 1, 2, 3 zeros after it. So whatever you would put on the bottom of a fraction when you're working it this way, that's kind of what you're going to do here. Well, actually, that's not necessarily true. It's the part that's repeating that matters. So I'm going to multiply this by 1,000. And when I multiply this by 1,000, that's going to move the decimal over 3 places. So instead of 1.125, and I'm going to copy the 125 again, I'm going to move the decimal over here. So I'm going to have 1125.125. You have to be careful to line up your correct place values so that your units place is over your units place, your tenths place is over your tenths place. Now I subtract on both sides. 1,000n minus n is going to be 999n. 1,125.125 repeating minus 1.125 repeating is going to be 1,124. So to solve for n, I need to divide both sides by 999. And that's actually in simplest terms, 1,124 999ths. That actually cannot be simplified any further. Okay, so that's number 3, which is just like number 3 in set 1. It just uses different numbers. Now, I'm not going to do number 4 because the number 4 in set 2 is not like the number 4 that's in set 1, and I'm having you skip the number 4 in set 1. So what we're going to do is go ahead and skip over to number 5. So number 5 says, if possible, find the rational number represented by this, x squared plus 1 over x squared minus 1. And you need to find the rational number. The rational number means write it in fractional form. Don't put it in decimal. You want a fraction here. Okay, so for part A, we're going to let x equal 0. If we replace both of these x's with 0, what do we end up with? Well, we have 0 squared, which is 0, plus 1, over 0 squared, which is 0, minus 1. Well, that's 1 over negative 1. That's just a negative 1. So we can stop that one there. For part B, we use x equals 1. Okay, so in our numerator, we have 1 squared, which is 1, plus 1. In our denominator, we have 1 squared, which is 1, minus 1. That gives us 2 over 0. That one is undefined. So you can actually write undefined, or you could write not possible, because it is not possible to write a rational number with 0 in the denominator. Okay, part C, x equals 2. So 2 squared is 4 plus 1. 2 squared is 4 and then minus 1. So I'm just plugging in my x value in the equation here. So 4 plus 1 is 5. 4 minus 1 is 3. That's a fraction in simplest terms. 5 and 3 are both prime numbers. One more, we're going to do part D, x equals 3. So 3 squared is 9. So we have 9 plus 1. 3 squared, sorry, that doesn't look very much like a 9. 3 squared is still 9, so we have 9 minus 1. 9 plus 1 is 10. 9 minus 1 is 8. This can be simplified because these are both even numbers. When I divide the numerator by 2, I get 5. When I divide the denominator by 2, I get 4. So 5/4 is our final answer. So this was number 5, and it's just like the number 5 in set 1, except in set 1, you're going to have a different expression that you're plugging into. Just be careful. If you end up with something where your denominator is 0, then it's not possible. You can write undefined or you can write not possible. Okay, so there's not actually time to work through number 6. So we will do that in the part 2 video.